The first time I broke into my neighbor's Wi-Fi, I was about 12 years old. Everyone was using web encryption at the time, so cracking the keys took just a minute. But from start to finish, it was actually a 6-month process for me of study and fooling around. Pretty rewarding in the end, but looking back, it was probably also super illegal, and I wish there were more tools out there to help me learn easier, not just hack Wi-Fi networks. That's because one of the hardest things about cybersecurity is there's no formal roadmap and a million different places you can start that lead you down a million other rabbit holes.
Here's an example. Let's say you wanted to figure out how a computer knows what type of file something is, because I'm sure you know changing the extension from PDF to PNG doesn't change its actual file type. You know that, right?
Maybe someone told you about the Linux file command, so you look it up in the man pages. You start to fall asleep reading this until you see the words magic tests. Oh, that seems interesting. So you search it up on Google and find a bunch of unrelated results. Now you've got to figure out how to customize your search query and start learning about Google's advanced search operators, which helps whittle away some of the results, and you finally find something that looks promising. GitHub seems close enough, but what's Laravel? There's some code and browser tests. Let me go back and put file in quotes. Stack Exchange, everyone's favorite. We get an answer explaining how certain files begin with certain headers. But now you're confused why PNG has backslashes but a Java class doesn't.
What is a Java class anyways? Is that a class on coffee? The guy linked to a Wikipedia article, but looking at it, you start to wonder if you should have just read the man pages in the first place.
By now you're burnt out and about ready to drop money on that 1-week cybersecurity bootcamp or crash course. And even then, you might end up feeling completely lost and not able to see how concepts fit together.
I've certainly been there, which is why today, I want to show you 5 simple things you should start doing to learn concepts faster and get unstuck more easily in your cybersecurity learning journey. And at the end of this video, I'll give you a quick demo on how I'd combine all of these methods to learn something new for the first time. Let's go. The first and most important way to learn cybersecurity faster and easier is to focus on topics related to your existing meaning structures.
You see, all of us come with some level of background knowledge in a field or area of expertise. There's a lot of things you already know and understand very well. The closer and more connected the skill you're trying to learn is to the stuff you already know, the faster it is to acquire. That's why it's much easier to get into cybersecurity if you come from an IT or computer science background. Fields that involve working with software, systems, networks, than if you came from another field, like being a mechanic, English teacher, or security guard, where your existing meaning structures are much further away. Jumping straight into a cybersecurity specialty like pen testing or threat intel because it sounds cool or pays well is so far removed from what you currently know that you'll waste a lot of time covering missing ground and getting stuck. Chris Sanders, who wrote a lot of great cybersecurity books and courses on blue team operations, explained it like this.
Learning is a complex thing. It requires approaching information in different ways. Things like learning styles, where people prefer like auditory versus visual, whatever, that's mostly a myth, and I haven't really found that's a true thing in research. Connecting with people where they are and their existing experience is a thing, and that's a very hard thing to do.
For people who describe themselves as visual learners, sometimes I wonder if it's because imagery taps into our existing meaning structures and makes new ideas more relatable compared to someone just talking.
Turn to page 394.
But fortunately, cybersecurity has a lot of different related subfields, so you can always find some niche that connects with what you already know. For the mechanic, it could be learning hard drive repair and data recovery, which then naturally tie into disk and memory forensics, useful skills to have on incident response teams. For the English teacher, you could start off learning to be a technical writer on cybersecurity topics, documentation for tools or security reports. For the security guard, you might want to start off by learning more about physical security operations and access controls, which could then tie into physical pen testing and software access controls. Even while you're studying a topic, don't just go in the order that information is presented. Find out what concepts are most proximate to what you already know and take a nonlinear learning approach.
Following this strategy might require you making a few extra hops, but in the end, it's going to help you build more knowledge and reach your final goal faster. But now you might be thinking, okay, what if I found a cybersecurity course teaching something that seems close enough to stuff I already understand, so does it make sense to pull the trigger and buy it? So I don't like poo-pooing on cybersecurity bootcamps and crash courses because I'm all for more resources and education out there, but I'm going to hate on them just a bit. Here's why. Get your 6-figure cybersecurity dream job now by attending our 5-day Telesere bootcamp and become a cyberspatial certified network cartographer. No experience required, you'll get all you need from our world-class instructors, so hurry up and give us your money today. Satisfaction guaranteed. See, the problem with short-term courses is they don't fit well with our biology.
People learn best by interleaving small doses of theory and practice together over time.
Not absorbing massive chunks of knowledge in just 1 or 2 weeks, where you'll probably forget most of what you'd learned versus spacing things out.
Our industry tends to shy away from college in a lot of ways. One of the things college does well is they space things out. There's a reason when you have a college course, it's spaced out over several months and not just packed into a week. And that's because a lot of magical things happen when we sleep and when we leave a topic for a certain amount of time.
When you're learning something new, oftentimes what you think is a mental block is actually a physical block that gets removed when you sleep on it. Your spinal fluid washes away the plaque buildup on your neurons, memories and emotions get solidified, and your neural pathways change in ways that help you understand the same thing from different perspectives.
Spacing out your learning schedule with more smaller doses is the best way to make this happen.
So instead of banging your head against a brick wall, sleep on it for a few days, and you'll quickly find ways to go over, under, around, or through it.
I understand boot camps and crash courses are going to be valuable for a lot of people, but definitely consider the biology of learning as well if you're dead set on doing them. So, what about university?
Does it make sense to go to college to learn cybersecurity, especially if there's a teacher you know and really like who works there?
Here's the deal. There's almost nothing you can learn in school about cybersecurity that you can't learn outside of school.
Back in the day, knowledge was tied up in institutions like universities, but now podcasts, digital books, web content have democratized it to the point of being free.
So you've got to ask yourself, what's the value I'm getting for the premium price I'm paying? And the answer is usually access to the teacher. For IT and cybersecurity, you're typically going to want teachers who are practitioners themselves. Otherwise, you'll just get a bunch of theory and research.
Which one of you can tell me the difference between an animagus and a werewolf? No one. How disappointing.
But too often do I find people asking to be taught
as if all they needed was to be shown how to do X in order to learn Y. Unfortunately, that's also what a lot of practitioners do when it comes to teaching.
Most people in information security who do education are practitioner educators. So they're practitioner first, educator second. The default thing that most people would think is, okay, I'm good at this thing, so I will show someone how to do this thing and then they will be good at it. That's not really how humans are. It's not just a matter of watching someone do something once and we've really got it, particularly for really complex tasks. And most of what we do in our world is pretty complex, relatively speaking.
What Chris describes is the curse of knowledge, where once you've gotten to a certain skill level, it's hard for you to see how others don't understand what you know, or that it's just a matter of showing someone how to do something. I struggle with that bias myself. To really get that transfer experience and skill from someone,
what you should do is ask teachers to assign projects that they know how to do, go through the trial and error process of doing it, while getting feedback from them during the struggle. It's that cycle of deliberate practice combined with feedback that makes you build expertise really fast. Not passive learning, not show and tell.
Which is why most cybersecurity folks will admit to you they learn the most on the job and not in school.
So rather than paying tuition to a school, where maybe a fraction of it goes to the teacher, you could just pay the teacher directly for their time, giving feedback as you're working through specific scope projects. If you can't find anyone or it's too expensive, team up with a group of peers who are a little more advanced in IT and cybersecurity than you are and pay them instead.
But now you might be wondering, what if there's just a ton of theory and background info I need to learn to be able to practice projects in the first place? It's kind of overwhelming. To handle these situations, you'll definitely want to be building mental models and systems for yourself as you're learning new things, instead of just memorizing stuff in isolation.
A mental model is just a way of organizing information. How we organize information helps us a lot more oftentimes than the amount of knowledge that we accumulate, because we can structure it better and access it in better ways. A lot of expertise is not so much about accumulation of knowledge, it's about better organization of knowledge.
Here's a few mental models in cybersecurity I find useful that you can use to organize knowledge.
The first is the OSI model, which has several layers describing how close something is to the physical hardware versus application software. When you're learning about tools or how something works, the mental model helps you think through which layers of the networking stack they interact with. Let's say you try to connect to something and there's no connection. Having the model can help you troubleshoot. Maybe you're not plugged in or have a bad cable. Maybe there's access controls in place. Maybe you have an IP subnet typo. Your DNS name servers aren't connected, or the remote server's down.
The more experience you have with this mental model, the easier it is to troubleshoot problems and figure out how apps work.
A second mental model is defense in depth, which basically means instead of just having a lock on the front door of your house, maybe you'll have locks on every other door too, with multiple security zones inside. And then you'll layer on cameras, guards, lights, attack dogs everywhere, not just the perimeter.
When you're learning about a network, device, or app, defense in depth helps you think about all the areas that can be exploited and need security controls. Two other mental models are timelines and minefields.
Timelines are useful for blue team ops, where you pivot from discovering one security alert to uncovering all the other events that happen on your timeline for a full story of what happened. On the other hand, for red team ops, treating your target network like a detection minefield can help you think about which areas have honeypots, endpoint protection, or extreme monitoring, which can then help you know which tools and techniques you should use to avoid getting caught by the blue team. As you learn about cybersecurity, you'll acquire a bunch of mental models and personalized frameworks that can help you handle any new topics or ideas you come across.
But what if you don't even know where to start or feel smart enough to build mental models in the first place? Like, you don't even have a good research process for gathering information. At that point, you should probably just give up. I'm just kidding.
When you're dealing with a lot of dense, complex topics, what I like to do is decompose the pieces using a mind map, which can become its own model. Kind of like how you need house blueprints to build a house or a network map to understand a network. The key thing is to be in divergent thinking mode, where you're thinking of all the possibilities from a single data point versus being in super focused analytical mode. When you come across a word or topic, write it down on a piece of paper, then connect it to other pieces and related topics. Continue connecting everything together until it's mostly mapped out. Then highlight the areas you don't know very well and do a focused deep dive to tie everything together.
Just make sure you're updating the mind map every now and then to keep track of how you arrived at a topic. During a job interview, when you're asked to explain how something works, it's going to be really valuable to showcase everything you know on the spot by retracing your mind map or mental model. So if I want to learn about file formats, like at the beginning of the video, here's my process starting with mind mapping. I'd begin by drawing some bubbles for file formats, maybe a few like PDF, PNG, then maybe think through what scenarios knowing about them would be important. Maybe data recovery, forensics, carving files from PCAP. I like to figure out the tools used to detect file formats and different tests those tools use. The man pages for the file command use file system tests, magic tests, and language tests, which we need to go read more about. There's also different flags I can use for the file command to explore. During a Google search for a magic test, I might realize the need to learn about advanced search operators, Laravel, Java classes, and different header types. I'd have to look up text formats for backslashes and what looks like hexadecimal characters, and learn about how data gets encoded and stored as a file, and maybe how files are stored on a file system. After building the mind map, I can then skip topics I'm not really interested in because they don't relate to any existing meaning structures for me, and then highlight the topics that do, like how files are stored on a file system, because I know a bit about formatting hard drives and USB sticks. If I have access to a teacher, I might ask them to give me some project ideas for carving files from disk or PCAP using a tool like Scalpel, then ask for feedback when I explain my workflow and process. If I didn't have a teacher, I could find a forensics, Discord server, or Slack channel and ask people for resources they know of that have guided practice labs. I'd set a schedule to spend an hour every day going through my mind map or practice projects for an entire month. This way, I'm interleaving theory and practice, spacing things out over time. As I'm learning more about the relationship between file formats, a mental model I could use is thinking of them like food in a grocery store, with the type of packaging used indicating the contents that are inside. I know it seems like a lot, but believe it or not, you've probably done all of this before in one way or another, even if you're just playing video games. Mind mapping ideas, picking the easiest, most relevant topics to learn first, practicing something, getting feedback from someone, and doing it in small doses over time. It's how we as humans learn, and you just need to apply them to other fields like cybersecurity. Are there any learning tools or frameworks you really enjoy using and want to share? Let me know in the comments below. If visualizing abstract ideas with simple tools is something you find really helpful, check out Telesir.com. We're building a network mapping tool for cybersecurity and IT practitioners just like you, so sign up to get notified when we launch. But that's it for this video on learning cybersecurity faster and easier in 5 simple steps. Like, subscribe, and share with others you know. Thanks so much for watching, and I'll see you soon.